an Algorand smart contract. So now the narrative has changed on Algorand. You don't have to learn a new smart contract language. All you need to do is, if you're a Python or a TypeScript developer, you already know how to build a smart contract. You just need to learn a little subset of data types and Algorand-specific functions to build a smart contract. So let's see how this is possible. When you're writing smart contract with Python code, we built this compiler called Puya, and that's going to compile your Python code down into Teal, which is the low-level assembly smart contract language that the AVM understands. Now, what's powerful about this is that your smart contract code can leverage all of the popular Python developer tools available. So the linters and the formatters that are available for Python, it works here as well. So you will be similar to building a Python. Now, if you're a TypeScript or a Solidity developer, I recommend you check out TealScript. So TealScript is a compiler that compiles the TypeScript code into Teal code. And again, 100% same syntax with TypeScript. It 11 formatters available for TypeScript. So the developer experience will be same as building a TypeScript project. So smart contract on Algorand is easy. And it's not just easy for Web3 developers, but we made it easy for any type of developer. Because this is the big obstacle. If you're a Web2 company, but you want to try out blockchain or build a blockchain product, you either have to train your developer to learn a smart contract language or hire an expensive blockchain developer. But now in Algorand, if your developer knows Python or TypeScript, they know this little subset of Algorand-specific details, and they can get straight to building. So you can spend less time training, less time hiring, and more on building your product. All right, now let's move over to a code demo that Joe is going to present. And in this code demo, Joe is going to, yes, please, give a round of applause for Joe Perry. He's the creator of TealScript, so if you have any questions about the language, you can ask him after the talk. But he's going to show you building a complete NFT membership smart contract with a working front end.
All right, awesome. Thank you, Chris. So like Chris mentioned, I'm going to be showing you what building in TealScript looks like. This isn't going to be a full like 0 to hero course on TealScript. Really the goal is kind of just to give you what the vibe of building on Algorand looks like. And then afterwards, we'll give you a challenge where you can kind of get your hands dirty and learn a little bit more about how TealScript development actually works. So what I'm going to do is I'm going to start off in a blank terminal and just show you how you can get started building with AlgoKit and TealScript. And then I'll go over to a completed project that has a TealScript contract and a front end and walk you through how we write our contract and then how we integrate that in our actual front end. So but first, if you're a new developer on Algorand, the first thing you want to do is install AlgoKit. Now, if you already have Python installed, then this is pretty easy for you. You just need to run a pipex install AlgoKit. And by the way, if anyone in the back, if it's too small for anyone in the back, just let me know. I can bump it even bigger. But to install AlgoKit, you just do a pipex install AlgoKit. And we also distribute installation scripts on Brew as well. So if you're on Mac OS and want to install AlgoKit through Brew, you can. And also on Windows, we support Chocolatey as a package manager. So you just run that and it'll install. I've already erased like the Wi-Fi going out in the middle of my presentation. So I'm not going to be showing you the actual install step, but it takes like a couple minutes to install at most. So once you have AlgoKit installed, if you run AlgoKit, it'll show you all the different commands. We don't have time to go through all these different commands. So what I'm going to be running as a first-time developer on Algorand. So the first thing we want to do is we want to init a new project. AlgoKit init, so if I do AlgoKit space init, is the command we want to run. And if you're like a Web2 developer, this is very similar to like create something like that. Gives you a project with recommended like plugins, recommended dependencies, but of course you as a developer can go in and change things after the fact. This is just the default template that we recommend that you start with to make your life a little bit easier. So when I do an AlgoKit init, it's going to, and this is basically a series of questions that helps set you up with the project that you actually want to build. So you can see here, the first question it asks me is what I'm building. I can either choose a smart contract, a dApp front end, or I can do both. Now, to start, I'm just going to start with the smart contract. So I'm going to go ahead and select that. And now you can see here, we have the option to build in Python, TypeScript, or this old language called Pyteal. If you're new to Algorand, just pretend Pyteal doesn't exist. It's honestly a pretty crappy experience. So we now have Python and TypeScript. So I'm going to go ahead and choose TypeScript. And as Chris mentioned, Python and TypeScript are just Python and TypeScript syntax. If you're coming from Solidity, because Solidity is ECMAScript based, you'll probably feel a little bit more comfortable with TypeScript. But ultimately, choosing Python or TypeScript is just about which language are you more comfortable in. They both can do the same things and provide a really compelling, even new to Algorand. But for this, because we're at EthDenver, and I assume some of the developers here are familiar with Solidity and TypeScript, I'm going to go ahead and choose that. And I'm just going to make up a name of project. I'll call it Hacker Mansion. And what this is going to do, start to initialize that project directory. And kind of curse myself here saying about internet going out, it seems to be hanging. So what this is doing is basically it's going to a template and then initialize it. So it doesn't seem to be loading right now, so I'm just going to go ahead and show you what the complete project looks like. So if we go over to what a project actually looks like, so here, how I got this directory ran Algorand, I gave the name NFT membership app, and here it created this directory. And now this is the directory structure that everyone that uses AlgoKit init, whether they choose smart contracts, whether they choose a front end, or they're using their completely own custom template, this is the layout that they all are going to. Level directory, we just have some stuff that's common to every Git repository. We have like a dev container, so you can use a code space or Docker. We have our git ignore file, and then our special algokit.toml file. This algokit.toml file tells AlgoKit, the command line tool, a little bit about our workspace. And in the future, we're also going to be using this file to define like orchestration commands. So for example, in your package JSON, you have scripts, or in your poetry .toml, I think it is, you have scripts, and eventually you'll be able to basically combine both of those in your AlgoKit toml. So this is the equivalent of like a package JSON for an Algorand project. But if we go down into this projects directory, this is where our actual code lives. So in this example, this is going to be an NFT membership app. So it's going to be a smart contract where you give it some amount of algo, and it'll give you back an NFT saying that you're a member in that smart contract. So we have our smart contract for actually doing that membership and the token minting and that sort of stuff. And then we have a front end to make it easy to interact with. So what AlgoKit does is for each different component of our dApp that we're building, we have a separate directory under our projects. So here, because this is a truly decentralized dApp, we don't have a backend, right? We just have our front end running in React that runs in browser. But if we were to have a backend, like a Django backend or an Express backend, that would just be another directory here under projects. So what I'm going to do is I'm going to start with the smart contract and then talk about how we actually integrate that into a front end. So in the smart contract template, you can see here that the folder is named TealScript, and this looks exactly like a regular like TypeScript project, right? We have our test directory, we have an ESLint configuration, we have a prettier toml file, we have a jest configuration, our package JSON, and our tsconfig. So because we're using native TypeScript contracts, tools that you know and use for writing any other TypeScript project. So this should be a fairly familiar layout. And then our actual code here, in Algorand, it's common practice to put your code under a contracts directory. Like for example, when you're TypeScript or React, you have Algorand. Our standard is typically put it under contracts, but your contract can go wherever you like it. And this is where our actual contract lives. So in the contracts directory, you could have a bunch of TypeScript files, and you can see here we have NFT membership app. Now, again, because we have the .ts extension, and we also have that .algo like sub extension, that .algo isn't necessary, but it's again common practice to use because it helps us differentiate our Algorand smart contracts and the rest of our type of examples, so we can tend to have different rules in our contracts and in our like front end code if we wanted to. But pop and open this file here. Basically what I'm going to do, like I said, this is already written, so I'm going to go through the code. I'm going to quickly show you just like the overall code of what it looks like, and then we'll kind of what it's actually doing. But taking a look at the high level, this should look pretty familiar to you if you're already a TypeScript developer. We're going to start off by importing our dependencies. Right now, we are just importing TealScript, our contract. We're going to be writing a smart contract and other contracts. So if you're a Solidity developer, you probably use like something like OpenZeppelin that gives you a bunch of like templates and pre-created contracts that you can inherit from. So we don't yet have an OpenZeppelin on Algorand, but that is totally possible with our tools for both Python and TypeScript. I mentioned that native TypeScript syntax, but we can't use TypeScript libraries. So I can't import a library that was designed to run in like a node environment in my contract, for example. So I'm only importing things from TealScript or other contracts that I've written with TealScript. Contract, I define a contract by instantiating or by defining a class, much like you do a regular TypeScript class. In this case, we're calling it NFT membership. And then we're going to extend contract. And extending contract does a couple of things. A, it tells our compiler that this is our smart contract class. It gives us access to contract-specific functions in regular TypeScript classes. Now, again, I'm going to quickly go over just kind of the layout, and then we'll go back up and kind of drill down into the details of what's happening here. But you can see it's laid out just like a regular JavaScript class, right? We have our properties here with our ts comments. We have private functions that we use internally within our contract. And then we have public methods that can be externally called by either other knows what NFT it should be giving people when they actually register. And one other important thing to note is that for our membership price, we are saving it in an unsigned 64-bit integer. This is one of the differences between Ethereum and Algorand. In Ethereum, the EVM natively works with 250 words. It's or the standard integer that it works with is an unsigned 64-bit integer. As Chris mentioned, you can work with up to UNT 512, but working with UNT64 is the most optimized integer type that you can work with, and it's the default. So for example, if I'm transferring someone some algo, the amount that I'm transferring is always specified in a UNT64. So that's why we're using that type here. Now, so that's our global state, and that's just going to be saved in the contract. So every time someone calls it, they're going to have access to the state. Now, our other type of storage is our boxes. And boxes, how we're using it here is very similar to how a mapping works in Solidity. What we basically want to do is we want to have this property called member info, and we want that to hold a map of an address to a Boolean. This is just going to be whether this address is actually a member or not. So we're just going to have a simple one-to-one. When someone calls a contract, that their address is going to be the key, and then a Boolean is going to be the value. And we'll see how we actually use these as we get into our logic. The first thing to note here is that we have the ability to define private methods. So just like in Solidity, we can have private and public methods. In here, we can do the same. By default, if it works just like TypeScript, if we don't define a specific keyword, it's going to be public. But this is going to be only callable internally within the contract. And what this method is going to do, it's going to do an assertion. So this is very similar to Ethereum, where you can assert whether something is true or not, or whether it's non-zero or not. So here, I just have a method, and it's just going to make sure that the sender, so the person calling this app, is the same as the person that created this app. And this is basically similar to like the Oakland Zeppelin ownable, where we're saying, basically giving access control and saying, whenever we call this function, it can only be by the person. If that isn't true and our assert fails, then our smart contract call would fail, and we aren't charged any algo, and we have to either call a method or get the creator to call it. Coming down into our first lifecycle method. So on Algorand, one of the unique things about smart contracts is that we can not only, of course, create them, but we can also update and delete them. By default, Algorand smart contracts are mutable, but if you're writing with TealScript or Python, they will be immutable by default. So the only lifecycle method we're defining here is our create. And so what this method is, it's going to define the logic we'll execute when we first instantiate it. So here, because we're creating our membership contract, we just want to be able to pass in our price and then save that in global state. So that's all we're doing here in our creation. So first create the contract, and that saves our desired price. And this is going to be the price of the NFT. Now, after we've created our contract, we can call our other public methods. Our first one is going to be create membership NFT. And this is going to be a method that allows us to mint that token. Arguments, we're going to be passing information. And because tokens are a native feature of the Algorand blockchain, we don't need to create another contract. We just send a transaction called an asset create transaction, and we can pass in all the information that we want here. So you can see, in order to find any extra logic, I just call this one function, and that natively creates an asset that'll have our name, the total that we wanted to create. We can specify how divisible it is through our decimals, our unit name, our asset URL, which will contain like our IPFS metadata. And then we also based access control methods. And now Algorand, because because we have assets natively supported in the blockchain, we want to give developers flexibility in how those assets behave. If we didn't have additional functionalities in our core ASA, so we have a couple of common features baked into our tokens that you commonly see in smart contracts. Now, all of these features that I'm going to mention are completely optional. So if you're minting a token, you don't need to enable these, but they're there in case you want to. So the first of which is clawback, specifying if an asset has the ability to claw back a token from any other address. So in our case, we're saying the clawback address is going to be the address of our app. So this is basically saying this contract can take the token out of anyone's address. And again, this is, and we'll talk about how we're going to be using this a bit later. But then we can also define another functionality of Algorand is being able to freeze assets. And both this and clawback are very useful for like regulated assets. So for example, USDC, they will not deploy their token to a network. So having this native functionality when you consider specific regulatory concerns for different implementations. So freeze, as the name suggests, allows a specific address to freeze the assets in another person's account. And then we also have our manager address, which can update these fields. Reserve address that holds the unminted token. So what we did is we called send asset create to create it, and then we just saved this value in our global state. So again, our membership NFT is the asset ID in our global state, and we're just going to save it by calling dot our created asset. So that's to mint a token on chain, which is just one single send asset creation transaction. So now that we've minted our token, we have this get membership function, and this is what users token when they want to sign up for membership in our app. Now the arguments here are a bit different than the arguments that we've had before. The arguments we had before behave just like you would expect them to. I pass a number, I can then use that number in my function. But these arguments are a little bit different in that these arguments are actually transactions. So one is atomic transaction. And when we have a transaction as an argument to a contract call, what we're saying is that these transactions must happen atomically. So I have this get membership function in my contract. I have this pay transaction as an argument, and I have this asset transfer as an argument. So this means whenever someone calls get membership, it must be grouped atomically with a pay and an asset transfer. And by doing this, I can now introspect these transactions and make sure they are what I expect. So if I look in here, we're just doing a couple of asserts to make sure our state is what we expect it to and that this person is. And then we verify the fields in these transactions. So I specified, for example, I have a payment, and this is going to be an algo transfer. And now I want to look at that payment and make sure that the payment is the amount of the membership price. It's being sent to this address, so the contract, and it's being sent by the sender. So what I'm doing is I'm making sure that when I call this contract method, I'm always paying the contract account, however much my membership price is.
I have a question.
Yeah.
Like in the first assert, what case would you have this assert fail? So if this membership NFT not exists, does it mean that the contract is not instantiated?
Yeah, so this would be not true when we haven't yet called our create membership NFT. So when we instantiate the contract itself, we call create application. And then once it's deployed, we need to call create membership NFT to actually mint that NFT. So if someone tries to get the membership before that NFT is minted, then that assert will fail. So we're verifying the atomic payment to make sure that we pay the contract the amount that we want it to. And then we verify our asset transfer. And this asset transfer is what we call an opt-in transaction. And this is basically a way to tell the ledger on Algorand that this user wants to receive this asset. By default, you can't send any asset to any address. Address specifically say, I want to receive this before anyone can send it. And this is helpful for spam and also helpful to make sure that people are paying for the assets in their account that is taking up space on the ledger. So an opt-in is basically a transfer from one account to its of amount 0. So once I do this transfer from myself to myself of amount 0, I'm telling the network, hey, I want to be able to receive this asset. And now, in this case, we're making sure that our transaction sender, the person calling get membership, is opted in. Once we verify that they are opted in, we can go ahead and send the asset to them. And again, we're not calling a contract, we're just calling send asset transfer, and this will execute an inner transaction that sends that asset from the contract account to the caller. Once we've done that, we're just going to go ahead and update our info and set that value to true to signify that this person has indeed registered. And now, if they try to call it again, this will fail because we are asserting that this membership value is either false or doesn't exist yet. Now, finally, we have our cancel membership. And what we're going to do here is basically inverse what we just did in our get membership. So we're going to make sure that the person calling this is indeed a member. And then what we're going to do is we're going to have the contract take back that asset. So when we created our asset, we specified a callback address, and that was this contract itself. And that means this contract can take that asset back from the user without them having to sign anything or do anything, without their control. So what we're doing is we're going to send an asset transfer. And what we're saying is we're going to be sending it from this contract account. And we're going to be transferring the membership NFT to NFT, so we're just transferring one. But the important thing here is that we're saying the asset sender, so the account that the asset is coming from, is our caller. So whoever calls our cancel membership function, they're going to lose their token. And we're transferring it back to this address. So if someone else registers, we can send that same token to them. Now, once we do that, we're just going to do some cleanup. We're going to delete our box. So delete that key value pair in our storage. And then we're going to refund them the amount of that it cost to register. So the whole life cycle of this app is first someone calls the create application, and then they create the membership NFT, and then anyone can come in and either get membership or cancel a membership if they've already done that. So that's what the smart contract looks like. Now to quickly go over what integration looks like in our front end. If we take a look in our contracts directory, so here in our projects, still in our tail script, under contracts, we have our artifacts. And these are the files that are generated when we compile this TypeScript code. Now, if you're an EVM developer, you're probably familiar with the ABI. On Algorand, we use a very similar ABI. It's not 100% the same, but a very similar ABI and ABI JSON specification where we describe the contract and basically all the things that it can do. We describe all the methods, that sort of stuff. And then we also generate our TL. So this is the low-level language that the AVM actually understands. But we don't actually want to deal with that stuff directly. We want to make our lives a little bit easier. So another artifact that we generate when we compile our contract is this auto-generated. So whenever we build a tail script or a Puya contract, what we can do is we can take that ABI information and use it to generate a type-safe client. So here it's about, I think, almost 500 lines of code, or even more, almost 1,000 lines of code that AlgoKit generated for us. And what this allows us to do is interact with our contract in our front end in a type-safe manner without having to write this basically like a broker between our front end and our contract. It does it all for us. So to see how that's actually used, I'm going to come over to now let me close this. I'm going to come over to my front end directory here. So close out of TealScript, go to front end, and I can see in my components, I have various components here to interact with my app. And these all these components, what they're doing is they're taking in that typed client. So when I build it in TealScript, I generate that typed client, and then to actually interact with the app, I use that generated client to interact with. So I can see here in this React component, I'm passing in that auto-generated type client, and I'm using that to call a function. In this example, I want to be able to call the on-chain cancel membership function, and I do that by calling type client dot cancel membership. So now without having to worry about how like the ABI signature and what the contract ID is and all this extra information I need to know about the contract, I simply just use this auto-generated client to simply call type client dot the name of my method. Now, before I go into more details, what I can do is I can show you this way. I can show you what this front end actually looks like. And then we can go into a little bit, show you a little bit more about the directory structure, and then we can have some Q&A. So yeah.
Just a quick question.
Yeah.
Those types that were defined on the smart contract, like asset ID and asset transfer transaction, are those coming from AlgoKit, or do you define those yourself?
So those type, like in the contract, those are types defined in TealScript, but they map to types that are also defined in AlgoKit. So in our front end, it's not like the same type, but there's a like one-to-one mapping of types in your contract. You have the equivalent type in your front end. Yeah, so I should disclaim that I am not a front end developer, so this is a pretty simple and ugly and probably poorly written front end, but it kind of demonstrates the power of AlgoKit for someone like me who can still write a somewhat decent front end pretty easily. So here what I can do is I can define a membership price, and because app ID is 0, that means I'm going to create it. I'm going to go ahead and create my membership. Actually, let me, before I do that, nope. Maybe first make sure I'm actually running it. So by default, the AlgoKit template comes with like a wallet connector library. And because I'm just on my local net, like I'm not connected to mainnet or testnet, the only option here for a wallet is our local net wallet. But if you were to switch to testnet or mainnet, which is done just like in an env file, then it would display all the different wallets that support Algorand as well. So as a developer, you don't have to worry about wallet integration. That's done for you by the AlgoKit template. But I'm just going to connect to my local wallet here. You can see I've connected this GB6 account. And I can come here, say I want to create a membership contract that costs 2 algo. I'm going to go ahead and mint that. And what that did is it created my contract. So on Algorand, every contract has a unique ID. On my local network, this is contract 1438. And it also created a membership ID. So if I take a look at what that looks like on the Explorer, you can see here, I've created a membership NFT. Now this is just a random NFT that I own, that I copied the image from. But the idea is that we were able to, on-chain, in our contract, when we first created it, we were able to mint an NFT, and we can now see that on the Explorer without having to mint other contracts. Like this is all just natively supported by the chain itself. So now that we've created our app and we see that we have a membership NFT, if I go ahead and click register, and I come back to my Explorer, let me see, let me quickly fix that. you as a developer wanted to implement like a timeout for the clawback, for example, you could create a contract, and that contract does the clawback, and in that contract logic, there's some like time component. So the native feature doesn't have like a time aspect. It's just like a Boolean, either it's enabled or it's not. But you can use smart contracts to add some more flexibility to that feature. And then how it works is, let me pull up the contract again. Script contracts.
So it's like an 1155 on ACID using Algorand?
Yeah, so basically how it works is that when we create the asset, we have a unique address, so, or a unique ID. So every time an asset is created, it has a unique ID that is returned in that transaction. And so this could be the asset that we create could be like an 1155. It could be more like an ERC20. It could be whatever kind of underlying primitive asset that we want it to be. But every asset that we create always has a unique ID. And so the important thing, if it is like a fungible token, for example, like Algorand has USDC. USDC, there's one unique ID for USDC, but it's a fungible token. So there's millions of different accounts that hold USDC, and it's always that same asset ID. So whenever we create our token, the network assigns it a unique ID, and that ID is just based on like the transaction counter. So it's guaranteed to be unique for every asset, and it's the same for apps. So every asset and every app, it looks at the transaction counter, and that's the unique ID for that. And then every time we want to like transfer that asset or configure that asset or delete that asset, that's the asset ID that we use to interact with the network. Does that answer your question?
Cool. Thank you. Yes.
All right, cool. Yeah.
Is there a way to test these contracts before deploying them to a network?
Yeah.
Or should I
Yeah.
repeat?
Yeah. Just,
My question was, is there a way to test these contracts before deploying them to a network?
yeah. So that is a great question. We actually do have tests, but I didn't go over it. So in this case, so because, first of all, because we're using our AlgoKit LocalNet, this is, it makes our lives easier because we don't have to worry about like dispensers or like using real money, of course. But also the block time on our LocalNet by default is like instant. And so this is really useful for like testing a contract. So here what I've done is I've written test using our contracts using Jest. Now, of course, you can use whatever framework you want to test. And we're using, much like in the front end, how we had that auto-generated client, we're using the same exact client here in our Jest test as well. And so here we have a bunch of different test cases for all the different methods here in our contract. And each of those, they're using that type client that we auto-generated. And if we want to run them, we go to projects tool script, and do an npm run test. It's going to use Just, and because we're on a local net with, well, first it's going to build it, and then it's going to run our test. And because we're on a local network, it just sends like a bunch of transactions super quick. So the iteration workflow with testing is pretty quick. So generally what we recommend is like the general life cycle is you build your contract, you write some tests against local network, as you iterate. And then once you're ready, we have a test net, like much like testnet on other blockchains, where it's the exact same software version as mainnet, just a different ledger. And then you can use that to like test with end users. And then eventually, once you're ready, you can go to mainnet. So that's what the general life cycle looks like. Yeah.
Is there a mock environment to test for, or only on local?
So there is, you can test on, we have a public testnet. So you can test on a testnet, and we do have, like part of AlgoKit, we have a dispenser built in. But because the local net is like instant block times, you don't have to worry about like dispensing. We generally recommend using that at least at first to start testing. Yeah.
Okay. Have you played with using?
Sorry, can we just wait for the mic?
Okay.
One. My question is, have you played with using ChatGPT to generate code? And if you had, what is your experience and what are your thoughts on it?
Yeah, so it's actually this is one of the really nice benefits of using like established languages like TypeScript and Python, is that these large language models like ChatGPT are already familiar with it. So I have used ChatGPT. In fact, I actually used it a lot. So if you go to the TealScript repository, there's like a bunch of examples, and a lot of those were actually written. A lot of the code was written by ChatGPT in GitHub Copilot, because at the end of the day, it's just native TypeScript. ChatGPT kind of knows like how to read it and how to write it. Now, of course, there is some like Algorand specific stuff that it doesn't know, but it is an extremely, still extremely useful to use, especially compared to like proprietary languages like PyTeal we had in the past.
So, what would it take for ChatGPT to know the Algorand specific stuff?
Yeah, so for that, you'd probably want to like fine tune the model. So you'd probably want to give ChatGPT like our Algorand docs, and like this would be easier like if you were using like the API to do it programmatically, or you like we're using a different model and fine tuning that. We actually have like on our Discord server, we have an AI bot called Kappa, and it's an AI bot that's trained on like all of our developer docs, our repos, and some other resources. And so that bot is really good at like knowing Algorand questions, but it doesn't write a ton of code. So conceivably, we could kind of like combine the two functionalities where you have something that's fine tuned for Algorand, but also has the general programming knowledge of like TypeScript, and get that experience. But we don't. That's not something we have right now.
Thank you so much.
Yeah.
Great. Do we have more questions, guys?
I have two more questions, but I don't know if you guys want to go with another.
Can we have one
Yeah,
more?
yeah, I mean-
let's go.
No, validators. If you guys need validators, I would love to talk to you about validators.
Yeah. So just like validators in the network.
Yeah.
Um,
Providing that for you guys.
Yeah, so right now anyone can set up a node and start validating. There's no like minimum barrier for entry, and it's relatively low like CPU cost. So the only thing you need is you just need some stake, and you just need to own some algo, and then you can spin up a
How
node.
much is this?
It's just 0.1 algo. There is no, which is like the minimum for the ledger. So there is no minimum amount.
And the other question was if you think that is it something that Algorand can support or grant to build the library for all these awesome features that you guys have here specifically on smart contracts, sort of similar to Open Zeppelin. If this is something that maybe we can even do it with the blockchain lab and support in the work that you guys doing and build like a library and get support or some grant or something, and we can build like a library of all these smart contracts similar to Open Zeppelin. Is this something, because there's none, I don't know how big could be, but I think it will be a cool project for you guys.
Yeah, definitely. I mean, the fact that we can now inheritance with like TealScript and Python are relatively new features. So like you said, we don't yet have Open Zeppelin. Right now, we don't. The foundation doesn't have a like direct grant program. We have a decentralized grant program called XGovs, so you can receive funding through that. I'm happy to talk to you a little bit more, after the workshop, and we can talk about what you had in mind and figure out the best way to go forward with that. But in general, yeah, that is something that we ideally want for both TealScript and Python, because I think that's a really compelling part of the Ethereum ecosystem is being able to leverage Open Zeppelin. So it'd be great to have that in Algorand.
Thank you.
Amazing, guys.
Thank you, Jeff.
Can I just go back to the slide?
Yeah.
Okay, so that was a code demo. Hopefully that demo kind of showed you how easy it is to get started on Algorand. But I know a lot of you guys love learning by coding. So we prepared this fun coding challenge for you guys. So the app that Joe showed was a simple one where there's only one tier of membership, but this coding challenge is for you to implement a multi-tier membership feature. So the smart contract should be able to create 3 tiers of membership, and based on how much algos users send to the smart contract, it should know what tier of membership entity to give out to the user. So we're giving you guys 2 weeks to do this. So the due date is at March 8th, so a week, giving you an extra week after December because I know you guys are super busy partying and meeting people. But yeah, we created a dedicated Discord channel inside of our Algorand server. So if you find EthDenver, Hacker Mansion, and ask your question there, Joe and I will be there, and also our other DevRels to answer your questions so that you can finish this challenge. We're also going to be giving out verifiable certificates for completing this, and it's this beautiful certificate that we created. But this is just yes, great. This is just not an image. This is also using the Go Plausible platform to create a verifiable credential. It follows the global standard for certificates and also includes a DID that follows the W3C standard. So this is actually a valid certificate that you can show, add it to your LinkedIn, and share to the world that you know how to build an algorithm. All right, I'm going to show you guys a couple of developer resources that you can leverage. Yeah.
I don't think we shared the link to the GitHub repo.
No. Yeah, it's at the end.
Okay.
It's at the end. Yep, there's a QR code that has everything. So I'll get there. Some developer resources that you can leverage. We have the YouTube channel, we post tutorials, courses, concept overviews. So this should be definitely the first step you go to. This you really can use for the coding challenge, but we have regular bootcamp. So if you really want to dive deeper into Algorand, there's one coming up in mid-March, right? Yep. So mid-March, so you can sign up for that and have a live session where you can ask questions, have coding sessions, and all that good stuff. We have the developer documentation where you can find everything about Algorand, but it's often hard to find information that you want. So like Joe said, we have a ChatGPT-like AI tool where you can ask your question and it will get you that answer. This is the Discord channel that we have. You can go here and ask your questions while you're building on Algorand. The DevRel team and our vibrant Algorand developer community are on there, always providing technical support. Now, if you like to just learn by looking at sample code, we have a separate developer relations at Algorand GitHub repo where we have a lot of sample applications, so you can just dive straight into the source code and learn from that. But this is the QR code that I promised you. This has the GitHub repo for the coding challenge, the invite link to our Discord server, the developer resources, everything, our socials. We would love it if you connect with us on their socials, share your experience from this event, what you think, what you didn't like. Just would love to connect there. So take this moment to scan this QR code. And if you're going to participate in the coding challenge, the Discord, if you go into the Discord server and find this EthDenver-hacker-mention, and that's a dedicated channel we created for you guys to ask your questions. But on that note, that's everything that we prepared for this presentation. I really hope that this presentation has taught you everything that you were curious about Algorand, what it's like. But this presentation wasn't really to tell you guys, oh, Algorand is great, come over, like build here. But so I really hope that this presentation has inspired all you to take a deeper dive into Algorand, see what's happening here, the ecosystem, what the technology enables you to build, and bring your ideas and build an application that's going to shock the world. Thank you.
All right. Well, thank you very much. Okay. Is this so?
Yeah.
Okay. Okay, guys. Well, thank you very much, Joe and Chris, for everything that you have shared with us today. Well, now I have another presentation to do. We'll have a fireside chat. Well, Benedetto, his flight got delayed, so we have Ibu. So please welcome. Hi.
Hi.
Welcome, welcome. Well, would you like to introduce yourself? Please.
Yeah.
Go ahead.
Hi everyone, I'm Ibu Corral, head of partnerships at Folks Finance. We got the core team still here in the audience, so grateful for everybody who's sticking around. Happy to talk about, the original talk was going to be do's and don'ts of building a startup. And now we're gonna do something different, answer some questions possibly about building a startup or going to market, growing the product. I don't know, it's up to Ava what she wants to do.
Of course. Well, the first idea was to make it this dynamic so you can participate with us, you can learn with us, we can learn from Ibu, from his experience. Well, Post Finance started a long time ago. We saw you growing, we saw every challenge that you made, but we would like to learn more in depth. So why DeFi? Why you choose a startup on DeFi? And why building that DeFi on Algorand?
You mind if I pull that chair?
Yeah,
You can
absolutely.
sit.
Let's go.
So, good.
Come here, Mark.
Sure, yeah. For all the viewers, this is very touch and go. So forgive our lack of organization, but it's about the content. DeFi is really, really promising, almost like a gold mine of opportunity in terms of you can clearly see an established industry, finance, money, been around since the beginning of civilization. And now you have a new way of interacting with it and a new way of building channels within it and building the ways that it will move around and interact with our world. So overall, the invention of smart contracts following the invention of blockchains really opened up just a huge, huge window. And I think it's still so early in the DeFi journey of industry that it was really clear to the creators of Folks Finance that it was a good idea to create a DeFi protocol. Now, the way it got to Algorand was the founder of Blockchain Italia became good friends with Silvio. They're both from Sicily. So I think because they're both Italian, this was early days of Algorand, almost no DeFi landscape to speak of. I think when they met, there probably were not even DeFi apps. I think it was pre-DeFi on Algorand. And the goal was to build a lending protocol, because lending is just such a key aspect of any financial ecosystem. You need somewhere to be able to put assets and borrow assets. So I think that's where it started, and we've come a long way and built a lot more. And yeah, I'd be happy to talk about that stuff.
Yeah, well, that sounds very interesting about knowing about Algorand in those early days. I mean, it probably was very exciting. So now, you got that idea about DeFi, is that gold mining, that I totally agree. I consider myself a digit, so I really know what you're talking about.
Yeah.
But then when you start building that MVP and building the product that now is Folks Finance, shining and brilliant, what were your first thoughts about having that MVP and start building actually the product?
So yeah, Folks launched originally as just lending and borrowing.
Yeah.
So that was the MVP, super basic tool with only the bare minimum of features included in it. You could deposit algo, borrow a couple other assets, but it served purpose for that time. Then the thing that really boosted Folks into a protocol, I think when we first launched, which was April 2022, we had about 3 million on the platform for a couple months. The following quarter, was when we launched the liquid governance with Galgo. That was what really took the product to another level of adoption. And then we iterated on Galgo to make it a better version, essentially, that you don't need to switch out every quarter. It just stays indefinitely. And then that really took it to another level again. So starting from the MVP, we knew that the lending was key, but because of the easy access yield on Algorand through governance, there had to be tools built to access that. Now, other tools were also built by competitors at the time, AlgoFi, Guard, but I think when you took into account the entire Folks platform, especially as we developed it over like the year and a half following that, it really became much more useful than the other platforms. So I think just simply from giving people very useful and very applicable tools so that they can use their Galgo, or dollars, or a lot of other assets as well. It just started to attract more and more people. And so, yeah, it was really about listening to what people wanted and kind of trying to fold it all into one big application.
Yeah, I think that makes total sense. I mean, hearing what community is trying to talk to you, and then like using the governance to make it easy for people to access. Actually, that is pretty awesome. And now, like when you're building a new platform, you're building a product, you're like jumping into the decentralized world, you have to build a team, and the team is everything. You can tell. And how the team, I mean, formed in the beginning. I mean, what were like the key skills that you need to put together, and how did you find it? I mean, all of you guys are amazing.
Thank you. Yeah, we have a really amazing team. I love everyone on the team, super skilled. I was not, I was maybe like the 10th employee.
Yeah.
So I wasn't involved in the earliest selections that happened between Benedetto and Pietro, who's the creator of Blockchain Italia, and they were hiring the real like original core team. But I knew that some people came from within Blockchain Italia. They were also they had maybe interned, gotten some students from like some good Italian universities. Other people, I think, our COO, our CTO, they just happen to be standouts, but I don't know the exact story of how they were found. But I think overall, to work for folks, and I would say most DeFi platforms, and it could even apply to most blockchain platforms, like anything in the blockchain industry, you have to be very, very willing to like go 2 extra miles, not just one, because that extra effort you're going to put in will end up making a difference over time. And so I think when we try to bring people into folks, they have to have that energy of like anything in blockchain of a startup is already a moonshot. So you have to know that going in, that it's not going to be a job where you can just like, chill out and work casually in your hours. Like it's not even really like a 9 to 5 job at all. It's almost like 24 hours all the time, because you never know when you could get a message, something can happen. If you're a developer, you might have to fix something in the middle of the night. If I'm doing partnerships, I might have a call at 4 a.m. with like someone in India or something, and like I'm gonna go that extra mile to make sure that it happens. So I think that's what we focus on, just making sure we have really, really dedicated and driven people, and still a small team. I think only like 20 people or less. So still making more of the sum of our parts.
Yeah, absolutely. And about going that extra mile, I totally get it. I mean, here you have the roller coaster that you have in blockchain, the decentralization, the community, the business, the product, the protocol, the innovation, and you can be behind. I mean, you have to run, and you have to put the now. Are you actually on building the version 3, or can we hear about what are you building at the moment?
Yeah.
Yeah, sure. So I don't know if we're saying it's the V3 because I think the V3 would be like involve a UI redesign or something like that. But I would say that folks is building what I view as like a DeFi V3 application. So think about it this way: if V1 was one application on one chain, you take like Aave on Ethereum. That was just one app on one chain, did one purpose. Then V2 is taking that app and kind of splitting it up between a bunch of different chains, which is what we see right now, because that was the simplest way to get your app on new layer twos and new layer ones that are coming up, especially if they shared the same coding language, which a lot of chains do with Ethereum. V3 of DeFi apps is like folks is in the position where we're able to now skip V2 and we can go straight to V3, which is natively accessible across many chains and networks, and the user is not having to stress about that at all. So we're able to, that's going to be coming soon, probably in about 2 months. We're going to be launching that using Wormhole and Chainlink. We're in the Chainlink build program, so we got early access to the CCIP, which is cross-chain interop protocol. And for anyone watching, that's going to be simply put, it's just a really powerful way to enable this DeFi V3 that I'm talking about. And as we go along throughout this year, more networks will be added to that idea. And of course, we're going to be able to take everything that we developed, learned, and like kind of cut our teeth in the Algorand world, bring it into the expansion. And then once Algorand is added to CCIP support, we can then fold in Algorand as well and allow the Algorand side of things to that entire like big network that we're building. I'm trying to come up with cool names for it. Yeah. And kind of is like a space station. Like so good. You know, like how sometimes there's concepts of a space station like a ring, has like a circular and then it has like an axis downstairs. Yeah, it's like an axis in the middle that like the spokes connect to. It's kind of how I started to imagine it. So let me know what you think of that name is.
I think we can come up with an idea with the community. And then one another cool thing that I saw in Fox, and I think that is the most cool thing that we can have is the multi-chain access. And that is, well, I think the future is multi-chain. We're building that on Algorand. But how do you see that growth? How do you project that on the future?
Yeah, I think not, of course, definitely multi-chain and interoperability is going to be, I think it's going to be one of the biggest talking points and narratives of the next couple of years, because we're just starting to get into much better options for how to do that. Last time around, like last couple of years, the bridges that were created were, you know, it was like a race to create bridges, a race to actually get something going, and a lot of them became very they were built unreliably. It led to a lot of money lost and hacks. So now, with a little bit of experience, I guess, even though it was only like 2 years of experience of the industry's had with bridging, it's getting a lot better. Some applications won't need to go multi-chain or cross-chain. But I'm going to say cross-chain because cross-chain is like accessible from any chain, and multi-chain is like the V2 splitting it. I just want to make that differentiation. But some apps will be best served to be on one chain. Like Algorand's specific strengths will be, especially for an application that the blockchain aspects are in the background and it's not for DeFi users, like Libondi with the tickets, like you're interacting with their website in a very secured and controlled environment. You don't really need, it's unnecessary to go to multiple chains. Yes. Maybe they'll add it, but I guess at this point it wouldn't be. But with the DeFi application, folks, like we have to continue growing. And so we have to continue to try to bring in new people. Yes. And I still maintain that folks making this step into new networks and then being able to establish some roots there, get our footing, and then bring Algorand in is by far the more beneficial way for Algorand overall. Because if we just had Algorand as a spoke of the whole system upon launch,
we would still have to go through some of those like trials and tribulations that I'm sure we will experience when we launch the cross stream. So I would rather, we have such a great like foundation of product and community and, you know, a lot of users and a lot of capital on Algorand. It's not worth it for us to risk exposing that to like a new thing so soon. It's better to like, let's get ready there and then we'll bring it in at the perfect time.
Amazing. Super excited about it. I would like to hear the community if we have questions, if you have comments, if you'd like to know anything about Fox Finance. For you all, well, we are live streaming. Just like my marketing team just said, like we have more than 100 people online. So hi to everyone. But yeah, I mean, thank you so much, Ivo, for this amazing presentation, for all the content, the information, and the data. I mean, deep data from Fox Finance, the team, the product, the growth, the future. I am very excited about this. So I would like to thank you. I would like to thank you, everyone, for coming here and attend our branch, our Hacker Mansion. You can review everything on our live stream or from the AlgoDev YouTube channel. We will also send to you all the QR codes and all the information that just Chris and Joe shared in the past presentation. But before finish this, I would like to take a picture for all of us. I mean, in the back or whatever, the team would like to. But yeah, thank you everyone for coming. It was a huge